All right, so the first couple should be pretty straightforward. You guys should all remember how to do these. Where do we find the vertical asymptote? In the denominator. So my vertical asymptote is x equals -3 because -3 makes the denominator equal 0. That's how we find it. That's my explanation. Your horizontal is y equals -2, the number at the end of the equation. Now, if you don't have x equals for the vertical and y equals for the horizontal, you're not going to get your full credit. So make sure these are both equations. Next, you're going to graph the asymptotes. So find on the x-axis, where is x, -3, and make dotted lines through a vertical line going through the x-axis at -3. Find where y is -2 on the y-axis. This time you're going to make a horizontal line going through the y-axis at -2. Now, it says draw your asymptotes and sketch your equation. Because this number is a +1, the graph's in the upper right and the lower left. And that's the graph. Okay, so that's my explanation. Because the numerator was positive, the graph goes into the upper right and lower left of the asymptotes. I didn't put an end model behavior. Let's look at that one. I thought, maybe I did. Hang on. This is the same equation. So let me just come back to this one, because to me the end model behavior just kind of goes together with this one. Your end behavior always matches. If there is a horizontal asymptote, that's what your end behavior matches. Because as x is getting bigger and bigger, it's getting closer and closer to where y is -2. So for your end behavior, you literally take your horizontal asymptote and change it from an equal sign to an arrow, because where the asymptote equals -2, the function itself is just getting closer to -2. So this arrow means approaches. So it's getting closer and closer and closer to where y is -2, but it never touches the asymptote, it just gets closer to the asymptote. So this is just going backwards. They want the equation of this particular graph. All right, so first of all, we know that our equation will be a fraction. Will this number on the top be a +1 or a -1? See, if you notice both of these corners, it's kind of like you're going one away from here. That's just a +1 because we're in the positive upper right, lower left. Remember, these are the positive. The top number's positive. If it would have been in these two corners, that would be a -1. Just always use 1. All right. The denominator always has x in it, and it's always x minus the x number. See how it's going through +1? This is just x minus 1 in the denominator. What number goes here? Where this is our vertical asymptote, was x equals 1. That's why the equation is x minus 1. The horizontal asymptote, where is the horizontal line going through the y-axis? At +4. So it's just +4. So you take x minus, this is always the opposite of this number for the x. That goes in the denominator. And where it crosses the y is what we add or subtract at the end for the y. did the end behavior on the previous one. This was the main one that I wanted to be able to review with you guys. All right, so there are two ways that we can look at this problem. First of all, we have to state the excluded values. Those are the values that make the denominator 0. Oops. I know that the test itself will be on paper, so we'd want to say x cannot equal 2, because that would make this denominator 0, and x cannot equal 0 because that would make this denominator 0. This is part of the answer. Please don't forget to state that. So our goal here is to get rid of the denominators. We want to have just a regular equation. So what we could do is just multiply through by the denominators in order to I multiply both sides by the denominator, and these cancel out. Oops, I canceled the right thing. Then what am I left with? X times, and always put this in parentheses. Okay, now the other way to get to this step, if there's nothing in common with the denominators, you can also cross multiply and get the same thing. X times x minus 7 gets us to the same step. -6 times x minus 2. Probably the biggest mistake people make here is they don't distribute. So make sure when you have parentheses that you distribute both sides. Now, in order to solve this one, this is the key factor here. X squared means this is a quadratic equation, so we need to get everything on the same side as x squared. So I'm going to add 6x, and I get x squared minus x. I get a minus the 12, so that everything is canceled on the right side and it equals 0. Then I need to factor to find out what my 2 zeros are, because x squared tells me there's 2 zeros. Then I need to factor. I know that these two numbers are factors of 12. 1 and 12, 2 and 6, or 3 and 4. These are my only choices. These are the only numbers that multiply to get 12. And so then they also need to subtract to get 1. So that means I need to use 3 and 4. In order to get a -1, the 4 needs to be negative and the 3 positive. So what this does is this allows me to find the zeros of this equation. What are the two values of x that make the equation equal 0? Our x equals -3 and x equals 4. Then we double check up here where these are my excluded values. I have to make sure my solutions don't match, which neither one do. These are my solutions and these are my excluded values. All right, so let's look at this one. Always start with the excluded values. So what makes x plus 8 equal 0? That means x cannot equal -8. And anytime x is by itself, we can't have 0. All right, so let me write this down. I'm going to show you both methods, but use which one you're comfortable with. All right. I need to get rid of both my factors in the denominator, so I'm going to multiply by x and x plus 8. So then I cancel out my common factors after I do that, and I'm left with x times x minus 7 on this side, 3 times x plus 8 on this side. But we can get to this step if you just choose to cross multiply you'll get the same thing. Now I distribute. Then since I have x squared left in the equation, I have to get everything to be over with the x squared. So I got to subtract both of these from this side to get 0. So now I have my equation. I'm going to write this up here. Since I have x squared, I need to factor to find my zeros. I need factors of 24 this time. We know we have x and x. Now I need to know what my constants are that multiply to get 24. Be really careful. 2 of these factors give you 10, but only one set of factors subtract to get you 10. Because it's going to be, oops, I do the wrong thing. Then I have to minus 12 plus 2, so my 10 is negative. That's why my bigger number here is negative and my smaller number is positive. Then what makes each factor equal 0, 12 and negative 2. And I come back up, make sure neither one matches my excluded values. So these are my solutions, and these are my excluded values. Both are needed for the final answer. All right, last one here. Let me just write this up here. So I only have one x in the denominator. That's this one. So that means my only excluded value, x cannot equal 0. If it helps, you could maybe put this whole side over 1. So I'm only going to multiply each side by x to cancel the x out, or just multiply this by x and this by 1 if you're cross multiplying. Either way, this is the equation that you're left with. Then we have to add the 3 so that the right side equals 0. Then I can factor to find my zeros. X and x, factors of 3 that add to get 4. Well, my only factors are 1 and 3, and to get negative 4, I need a negative 1 and negative 3. My 2 solutions are x equals 1 and x equals 3. Neither one match the excluded value, so they're both good.